So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to crude oil. So what is crude oil? Well, it's a mixture of a large number of compounds. Remember mixture again? It's lots of different types of molecules and atoms which can be separated. They're not chemically joined to each other. It's obtained by drilling through rock, so again it has a huge environmental impact. Most of the compounds in crude oil are hydrocarbons. Now these are molecules containing only hydrogen and carbon atoms. Now in the exam, if you miss out that crucial word only, you won't get the mark because there are lots of molecules that contain hydrogen and carbon atoms, but hydrocarbons contain nothing else. So you must say they contain only hydrogen and carbon atoms, and most of these are alkanes. Hydrocarbons. So the majority of hydrocarbons in crude oil are alkanes. Now these are saturated hydrocarbons. Now what that means is that they have only single bonds, no double bonds. Now that word only is crucial. It's not good enough just to say they have single bonds, because all manner of hydrocarbons have single bonds and double bonds and triple bonds and goodness knows what else. But saturated hydrocarbons have only single bonds. And this shows the displayed formula for an alkane. It has only single bonds. They have the general formula CnH2n plus 2. Properties of hydrocarbons. Now different hydrocarbons have different chain lengths. For example, C12H26 is longer than C3H8. Now the different lengths gives the molecules different masses. And the different masses affects their boiling points and melting points, because larger, heavier molecules require more energy to break free from the liquid and evaporate. Chain length also affects their viscosity or stickiness. Long chains tend to get more tangled, so they flow less freely. Also, as longer chains evaporate less easily, they're less flammable, because it's the vapour floating around the surface of the fuel that actually ignites, not the liquid bit. So, let's summarise these trends in properties for hydrocarbons. So, as the chain length increases, the boiling point gets higher, the flammability decreases, and they get more viscous, thicker or stickier. So when you're looking at boiling and melting points, just remember that large negative numbers are colder than small ones. Fractional distillation of crude oil. Now, crude oil is a mixture of hydrocarbons of different melting and boiling points, so it can be separated by distillation. This is evaporation followed by condensation. So learn these steps. This involves heating the oil to 350 degrees, allowing the compounds to evaporate. Any liquids flow to the bottom, but vapours rise up the fractionating column. The vapours cool as they rise, and the vapours condense as they cool to their boiling point and flow out through a pipe. So here's the fractionating column. The vaporized oil comes in at the bottom on the left. It's hotter at the bottom, so hydrocarbons of higher boiling points condense here. So we're talking about the longer chains, the residue, the tar, the bitumen, the sticky stuff. And it's cooler at the top, so hydrocarbons of lower boiling points condense here, the more negative numbers. Now just remember that each fraction still contains a mixture of hydrocarbons. It's not a pure hydrocarbon that is separated at each point. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.